just wanted to restate Federica's answer to Mike for hay. If you know the properties of hay very well, and you go through your haystack and say, I don't know what this is, but it doesn't look like hay. You don't need to have a match filter looking for a needle in a haystack if you know hay very well.
And who said NASA couldn't speak to Middle America?
Now, as a New York City resident, my impression is if you go through hay you don't want to do it with your hands. But I defer to you on, yeah.
We have no choice, but AIML would be good.
Yeah, I think AM, yeah. So I want to, in the final minutes we have here before the public session, look to the future. I think a lot of us have looked at the data we have now with a sense of dissatisfaction and say, what data would you want and how would you want to collect it? And just think about, we don't need to design the detectors, but think about the characterization that we'd like, what wavelengths we'd like, and just to kind of throw that out as one way to think about what we might want to recommend. Paul.
So one thing that strikes me in that question is that I'm not totally certain that we've dedicated our time and effort to looking for anomalies. I think by default there are some science communities that look for things like the genesis of a hurricane or a harmful algal bloom in the ocean or something in interstellar space. But I'm not sure we ever focused our interdisciplinary effort on that. And I think the question you ask is a really interesting one, part of our statement of task, right? But I'm not sure I can answer that quite yet. That's how I feel about that one.
Sure.
Shelley Wright. Yeah, going along with Dr. Bontempi's point there, we heard a lot from Arrow about specifics about the needle, 1 to 4 meters in size, 0 to Mach 2. You can then look at NASA's assets, right, and look at its spatial resolution, its spectral resolution, in particular the frame rate. I'm going to get to your question here, Dr. Spergel. You can look at the current NASA assets and try to say which ones could find that needle, the ones that Dr. Kirkpatrick put forward. That analysis has not been done. So one of my recommendations would be for NASA to convene a group and a task force to look at its current assets to calculate what current available data, and current facilities could answer insight into that. Now, to get to your future question, looking at this, I see Walter, is frame rate. I see a really big issue with frame rate. So if you want to catch fast-moving objects, you need to take quick images. If you want to get to these very small sizes and resolution, depending on altitude, where you're taking your image from ground or space, NASA will likely have to increase its frame rate into its detectors.
I think a short answer to what NASA's current assets would be able to see would be really big haystacks that are moving very slowly, which I think is the point that you're making. But that doesn't mean that that data is not useful, because if it's able to characterize the background extremely well, that gives you a better idea of what unusual looks like. Basically, anything that you do that characterizes the background will contribute to an understanding.